This is skills practice 40. We're doing colligative proper practice, and this is done by True Exactor. Okay, two important concepts that you need to know before starting this exercise. You need to know molality, which is M, which is equal to the mole solute over the kilograms of solvent, and you need to know delta T, which is equal to Van Hoff's factor multiplied by molal concentration of solute particles multiplied by the molal freezing point / depression constant. Also, you can use the boiling point constant. So overall, you know that delta T is equal to I times Kf multiplied by the M. I is equal to the number of particles, Kf is equal to the freezing point / boiling point constant, and M is equal to molality. Question number 1. What is the molality of ammonium ions at 1.75 solution of NH4,3PO4? NH4,3PO4 breaks down into 3 NH4 to the positive, which is positive, and PO4 negative 3. Since you know that 1.75 molal solution, you do 1.7 times multiplied by 3 to get 5.25 out because you have 3 particles of ammonia. Question number 2. What is the total molality of particles in the solution in question number 1? Since NH4 is 3 times, which is a 1.75, you get out 5.25. Then you just add the 1.75 for the last particle to get a total of 7 for the molality. Question number 3. What is the total molality of particles in 1.75 solution of sugar, a covalent compound with the formula C6H12O6? C6H12O6 goes to C6H12O6. The solid goes to an aqueous form. It will not break apart because there's no metal, so it's just 1.75 M. Question number 4. Calculate the freezing point of 0.75 molal solution of Al2CO33. Al2CO33 goes to 2 Al positive 3 plus 3 CO3 to the negative second. So you have a total of 5 particles. Delta T is equal to I times Kf times molality. So you have 5 particles multiplied by negative 1.86 degrees Celsius over M, which is the constant, multiplied by 0.75 Al2CO33. This will give you an answer of negative 6.95 degrees Celsius. Question number 5. A solution is prepared by placing 72.8 grams of calcium chloride into 120 grams of water at 22 degrees Celsius. The vapor pressure of the water is at 22 degrees Celsius is 2.6 kPa. That's a lot of information, but don't be afraid because we can tackle this problem. CaCl2 breaks down into Ca plus 2Cl, 3 particles. 5a is asking what is the boiling point of the solution. So you know that delta T is equal to I times Kf times molality. So delta T is equal to 3 times the boiling point constant multiplied by 0.655 moles, which you figure out by using the molar mass of calcium chloride, and all over 0.12 kilograms, which you figure out because you have the water, which will give you a final answer of 108.4 degrees Celsius. It's basically plug and chug, guys. What is the freezing point of the solution? You have delta T equal to I times Kf times M. Delta T is equal to 3 times the freezing point constant times 0.655 moles all over 0.12 kilograms, which is equal to negative 30.4 degrees Celsius. All you changed was the boiling point constant. Vapor pressure, this is a little bit different. It's the mole ratio, which is equal to the vapor pressure ratio. So you have mole solvent over mole solution, which is equal to the pressure of the solvent over the pressure of the solution. So mole solute plus mole solvent will give you the total of the mole solution. Not too difficult. What is the vapor pressure of the solution? So you have mole solvent over mole solution equal to pressure solvent all over pressure solution. So you have 0.15 all over 0.80532, which is equal to 2.6 all over x. 2.6 you're given in the problem, 0.15 in the 0.80532 you have to solve for, which you're given in the previous slide. When you solve for x, you get out an answer of 2.4 kPa. Question number 6. A solution is prepared by placing 72.8 grams of magnesium chloride into 120 grams of water at 22 degrees Celsius. 6a. What is the boiling point of the solution? So MgCl2 breaks down to Mg plus 2Cl. Delta T constant, delta T equation, you already know that. So you have delta T, which is equal to 3 times the boiling point constant all over 0.7639 moles all over 0.12 kilograms, which gives you a final answer of 109.8 degrees Celsius. 6b and your final problem. What is the freezing point of the solution? You're given MgCl2 goes down to Mg plus 2Cl. All you change is the freezing point constant, and you get out an answer of negative 35.4 degrees Celsius. I hope this tour was helpful.